Solve the equation 4 cosine squared theta plus 4 cosine of theta plus 1 equals 0. We recognize that this is a quadratic equation where if we let u be cosine of theta, then we can rewrite this equation as 4u squared minus 4u plus 1 equals 0. We then attempt to solve this quadratic equation to get u. Once we get u, we would need to let cosine of theta equal to u and solve this equation as well. First, we try to factor this. 4u squared minus 4u plus 1 can be factored as 2u minus 1 times 2u minus 1. We still need to check this. 2u times 2u is 4u squared. 2u times minus 1 is negative 2u. Negative 1 times 2u is another negative 2u. So that makes negative 4u. And negative 1 times negative 1 is positive 1. This is a zero product. So we have 2u minus 1 equals 0. And another 2u minus 1 equals 0. Although this is the double root here, 2u equals 1, so u equals 1/2. The same thing on the second factor, u is 1/2. We say that this has a multiplicity of 2, or the double root. Now that we found u, but u is not the solution we're looking for. U is cosine of theta, and we found that u is 1/2. We now solve this equation. Using the unit circle, cosine is defined to be the x-coordinates, and in this case, if we replace cosine of theta with the x-coordinate, we will get x equals 1/2, and we then draw the vertical line x equals 1/2. We see that this vertical line intersects the unit circle at two places where the x-coordinate is 1/2. Another one in the fourth quadrant where the x-coordinate is 1/2 and the y-coordinate is negative. From what we know with the unit circle, the only angle that determines the x-coordinate 1/2 in the first quadrant is pi over 3. Similarly, the only angle that determines the x-coordinate 1/2 in the fourth quadrant from 0 to 2 pi is the angle 5 pi over 3. So the solution we're looking for are theta equals pi over 3 plus 2k pi, and theta equals 5 pi over 3 plus 2k pi. We add 2k pi because this is cosine, and we can go around counterclockwise or clockwise every 2 pi. So this k is an integer and it can be negative.